We're back in section 6.3. This is page 400, check your understanding. We're going to revisit Mrs. Desai's class from the last problem. We defined x equal the number of Patty's correct guesses. So we remember if you remember back, we were looking at a binomial distribution with n equal 10 and p equal to 0.2. It was multiple choice multiple choice test with questions having options from A through E, which is where the probability of 0.2 came from. So for the first part, it says find mu of x, interpret this value in context. So mu of x, remember as always, is equal to our mean. So we're looking at the mean for this binomial distribution. Now if we go to our resource packet, it gives us the formula for that mean. The mean for the binomial is different than the mean of other ones we've been looking at. So again, in our resource packet, it says if x is a binomial distribution with parameters n and p, then this is the formula we used in the last video for finding those precise values. Now this is the formula you're using for finding the mean. The mean of x is equal to n times p. So here we would have mu of x is equal to n of 10 times p of 0.2. And we know that that is going to equal 2. So to interpret that, if many students took the quiz, we would expect students to get about 2 answers correct on average. The thing I like about binomial distributions is it just makes a lot of sense. That probably makes a lot of sense to you. If I had asked you without teaching you any kind of math, any kind of statistics on it, and just asked you what would you expect or how many questions would you expect people to get right, you would probably be able to come up with doing that same math. It's math that makes sense. It's not anything that you have to like really think of or memorize or anything. So then the next question says to find sigma x and interpret this value in context. Again, we're going to go to our resource packet. In our resource packet, we're going to get the next formula. So sigma x is equal to the square root of n times p times 1 minus p. Our n is 10, our p is 0.2, times 1 minus p is 0.8. And that one requires a little bit more math to be done. I can't do that one in my head. And we get from the calculator 1.265. And again, to interpret that, if many students took the quiz, we would expect individual students' scores to typically vary from the mean of 2 correct answers by about 1.265 correct answers. Same interpretation as we always give for standard deviation. How much on average do we expect it to vary from our mean? Our mean this time was the 2 correct answers, so we're expecting it to vary 1.265. All right, then the last question here. What's the probability the number of Patty's correct guesses is more than 2 standard deviations above the mean? And we're going to show our work for that. Okay, so we want to go 2 standard deviations above the mean. So we're going to find the probability that x is greater than our mean of 2 plus 2 standard deviations was 1.265. Then to clean that up, we're looking at the probability that x is greater than 4.53. Now again, with the same idea, this is following a binomial distribution, so instead of greater than, we're going to turn this into something that we can do with what we have, either a formula or with the calculator. So we're going to change this to 1 minus the probability that x is less than or equal to 4, because remember our binomial is a discrete random variable. Then from there, we can use the calculator to help us. we would do 1 minus math probability, whoops, go to binomial, sorry, that doesn't look right. Oh, that's why. Sorry, don't do that. Distribution is what we want. And going down to binomial. Probabilities, when we're using the other formula, that takes a little bit more work. I'd rather do it this way. So yes, it's 10, it's 0.2, our x value is now 4. Binomial CDF, okay, that should be good. And that was 0.0328. So putting those ideas together, remember this formula came from our resource packet, this formula also from our resource packet, and then applying that using the calculations, either the resource packet or purely through your calculator.